So guys, what I want to demonstrate to you today, set this down. What I want to demonstrate today is a skill that you might find useful. One of the things you should know as a radio operator is how to use a compass. It's also a good skill for men to have, but having a general idea in which direction things are in, you can use this for direction finding, like taking resection bearings. The other thing you can do with one of these is you can actually measure distance to an object, like my tower out there, or you can also measure the height. Now you might be saying, well, I got a tape measure, I got this or I got that. Yeah, but one of the things you can't do, say you want to put an antenna up on the top of a tree and you want to know how tall it is, or you're worried about a tree falling down and hitting your tower and you want to know, is it something that could be an issue? That's what you can do with a compass like this. Because this compass, in addition to being, doing this one-handed, a lensatic compass, also has, that's locked in the, there we go, is an inclinometer for measuring, looking up, measuring angle. So what I'm going to show is how to do this, and then we'll go inside and we'll have all the measurements down on pen and paper. So the first thing you're going to do is you're going to want to pick a point. Now I will tell you that I know roughly this is about 100 feet to the tower, because I run a cable all the way here around the corner to my radio shack. So, and that's about 120 feet. So I'm going to guess I'm at about 100 feet where I'm standing. And we're also going to shoot my tower to the thrust bearing because we know it's about 50 feet. We're going to have to take into account that you can't tell in the video, but I am a little bit lower than where the tower is. So it's probably going to read a little bit more than 50 feet. So the first thing you want to do, and it's not important, any of you guys that ever did topo maps, was when you set your compass to read magnetic north, we're going to be getting the difference in bearing on two angles. So it's not crucial to set this to magnetic north, because we're just going to get an azimuth and another azimuth. So what we're going to do, and I'm not actually going to do it because it's impossible to do on the phone, but we're going to point the crosshairs in the compass that you see right there to the target, which it's not going to focus, but the base of my tower where my boxes where my cables come into. So we're going to shoot that, and I know that that is 192 degrees. So the next thing we're going to do is we're going to turn 90 degrees either to the left or the right. If you turn to the right, you got to add 90 degrees. And if we're going to turn to the left, you subtract 90 degrees. So if I shot an azimuth of 192 degrees, that means I'm going to turn by looking at my compass. I'm going to turn until I get to 102 degrees, because that means I turned 90 degrees. Now the next thing you're going to do, and it can be any distance, I'm just using 10 feet because it's easy, is we're going to count off 10 feet. So, and I know I've already kind of paced this out, and I'm just showing you. And then we're going to come here and we're going to shoot another azimuth the exact same way we have done before. And we're going to come up with a reading of 198 degrees. So now that we have those two, and I'll show you on my pad and paper here, we're going to subtract 192 degrees from 198. And that's going to give us the angle. So we shot our first azimuth, we got 192. We turned 90 degrees, went out 10 feet, shot another azimuth, we got 198. That gave us a angle of 6 degrees. So we're going to use the the tangent function on our calculator. We're going to punch in 6 degrees, and we're going to get this 0.105, and then we're going to divide by 10, and that's going to give us 95 feet. And I know that's correct. So the next thing we want to do is we want to use our inclinometer. So now we're saying, let's pretend that I'm running cable. I already ran cable around the building, but let's just pretend I'm running cable from here. So now I go, okay, I need 95 feet of cable to get to the base of the tower. We're going to round off to 100 feet, right? Now I want to know how, we know that's a 50-foot tower, but let's just pretend we don't. Let's pretend it's a tree. So I'm going to use my inclinometer, and same thing, I'm going to take those crosshairs that you see that are focused on the camera, and I'm going to go right up to the thrust bearing. And I can't do that with the phone here, but anyways, what it ends up coming out to is 30 degrees. So what you do is let's see if I can do this so you guys can kind of see. So you're looking up and you're putting the crosshairs on the tower. And I'll punch this all out on the calculator for you inside. So so from standing from this point to look up to the top of the tower, it's a 30-degree angle. So now we need to take the tangent of that, and it comes out to 0.577. And we're going to multiply that by 95. So let me pause the video and go inside and show you guys that. So guys, normally I would just punch this into my phone, but I'm using the phone to make the video. So let's just show you. We'll do this real quick again. So we got the angle here, and to figure out this distance, we're gonna do the tangent of 6 degrees, I should say. So punch in 6. We go to our trigonometry function, tangent, and we got 0.105. which is right here. Whoops, sorry guys, right here. So the next thing we're going to want to do is we're going to want to divide that by 10. So 10 divided by 0.105. And we came up with 95 feet. So that's pretty handy. The next thing we want to do is we want to know, all right, well, how far up this unknown tower? And I know I'm just using a tower because we all know what that is, and I'm showing you that this math function is pretty useful. So we're going to want to clear this, and we're going to want to get the tangent of 30 degrees. Let me just punch that in. Comes out 0.577. And I know I wrote that like divide, that's just incidental. We're going to multiply that, and I'll show you. So 0.577 multiplied by this distance here, 95. Hopefully it should come out around 50 feet. There you go. 54.815. So with all of that said, you know, I would just say, you know, to get to the building, I'm going to call this about 100 feet, right? And they're saying it's 55 feet. We know it's a 50-foot tower, and I explained that there's a little bit of difference in elevation. And so at that point, you know, I would probably just be on the safe side, and it says 54 feet, right? If we're running cable, you're going to want to figure maybe a little extra. So I might say 160 feet of cable to get the job done. But that is how you can use one of these, a lensatic compass. You know, there's plenty of uses for it. Like I said, you want to know how high up, you know, like in like a fieldcraft type situation, you know, if like you were crossing a river and you had a group of people, maybe you'd send your strongest swimmer across to put a safety line. You want to know how much rope you're going to need. So anyways, just want to show you guys. Thanks a lot. Radio Man out.